This is for 4.2 college algebra, how we graph a rational functions using all these 9 steps. This time your function is from question 7. So question number 7 is asking us to graph the function of h of x equals to x over x squared minus 9. Again, step 1 in this case is to factor this. So if we see any common factor, we can cancel them out. X is the x, we cannot factor x, but x squared minus 9 is the perfect, what we call as a perfect square binomials. So you get an x plus 3 and x minus 3, that is a factor for it. So there's nothing can be cancelled here. So in order for us to find the domain, your denominator cannot equal to 0. So what you have here is x is all real numbers except for x equals to plus minus 3, where the 3 plus and minus came from the denominator. And if you look at your numerator power in this case is 1. And your denominator power in this case is 2. Again, this power is used to determine step 7 about how step 6, how do we figure out is that we have a horizontal or a slant asymptote. Next, step 2, we want to find the y-intercept. In order for us to find your y-intercept, you substitute all your x to become 0. So you have to find h0. So you got 0 over 0 squared minus 9. 0 over by any number is still going to be 0. So in this case, your y-intercept is at 0, 0, which is at the origin. So you notice that on the graph, it will cross over at your origin. X-intercept is where you set your numerator becomes 0. Our numerator in this case is just x. So we just set x equals to 0. So in this case, our x-intercept is also at 0, 0 at origin. So in this case, that is telling us that this graph will be intercept at your origin. Okay. We do not have a hole here for step 4 because there is no common factor. We didn't cancel anything early on in step 1. So hole in this case does not exist here. Step 5, we have to find what's the vertical asymptote. So in order for us to do this, you use the denominator equals to 0. So you set the x plus 3 and x minus 3 equals to 0. So x in this case is a plus minus 3. So in this case, we do have 2 vertical asymptotes. One is at negative 3 and one is at positive 3. And again, in the class, if you don't give me x equals 2, you just give me plus minus 3, you will get points off. Same thing in your online homework, they will mark you wrong. Step 6 is where we figure out your horizontal or vertical asymptote. So this is where the power comes in. So the numerator power in this case is 1 and the denominator power in this case is 2. In this case, power 1 is less than power 2. So this has a horizontal asymptote at y equals to 0. Y equals to 0 in this case is your x-axis. This is your horizontal asymptote. Y equals to 0 or x-axis. So again, you need to put y equals 2. Without the y equals 2, I will take points off in your test. Next, step 7, we want to figure out if this horizontal asymptotes the graph will cross over at your horizontal asymptote. How do we figure it out is you take back your original function h of x here, x over x squared minus 9, and you make it equal to 0. And where is this 0 come from? It comes from step 6. If this is 5, then you just need to make this equals to 5 and try to solve for x. But in this case, it's 0, so we will use 0 here. So solve for x, so I multiply x squared minus 9 in both sides. So you find out that 0 times x squared minus 9 is going to be 0. So in this case, we solve for this, you get x equals to 0. So when you get x equals to 0, that means it's telling us that this graph will cross over on the horizontal asymptote at 0, 0. So that's the reason why that when you look at this graph, this is the horizontal asymptote and it will cross over at 0, 0. So far, we only get 1 point here, 0, 0. Okay, the rest of the graph is not shown and you only get your vertical and your horizontal asymptote. So how do we figure out what this graph looks like? This is where step 8 is used. Now, step 8 is where you figure out your behavior for this function x over x squared minus 9 based on your vertical asymptote of plus minus 3. So early on in step 5, we find out that your vertical asymptote is plus minus 3. So you want to figure out if this function is h of x is positive or negative infinity. Positive infinity means that it goes up like this. Negative infinity means that it goes down like that. So how do we figure it out is this time you got to do 4 cases because you got two vertical asymptotes. So one is a negative 3 plus, one is a negative 3 minus, one is 3 plus, and one is 3 minus. Because this time you have two vertical asymptotes, you have to perform all 4 of this. So how do we figure out the end behavior for the negative 3 minus? That means we want to find a point that is very close to this negative 3 on the negative side. So we will use this point, which is negative 3.0001. So that's why we pick this point. We want to get a number so close to negative 3 that you will push the limit to infinity. So we plug this negative 3.001 into the h of x function here. So negative 3.001, then square it, and then minus 9. Now this is a negative because it's a negative number. When you square this, you will get 9.0000 something. Minus 9, you still end up with a positive number. So negative divided by positive, this is a negative infinity. So this telling us that at negative 3 on the left side, your function will go to the negative infinity. So this will goes down to negative infinity. So that means that we know this graph will go like this shape, like a curved shape like this. And the reason why is because we figure out this goes to negative infinity and you cannot cross on the horizontal and your vertical asymptote. So it goes curvy like this. Next, we need to find the end behavior for negative 3 plus. A negative 3 plus means it's a negative 3 on the right side. So this is a number we will use somewhere close to negative 3. So we will use negative 2.9999. So plug this back into the original functions and you find out that this number is a negative, the top one. The bottom one, when you square it, this come out to be 8 point something. It's very close to 9, but it's 8 point something. But when you subtract 9, it becomes negative. So negative divided by negative, it becomes positive. So this telling us that at negative 3 plus, your function will be a positive infinity. That means that this arrow will be on the positive, will go up because it's positive infinity. And then we figure out, this is for the negative 3. So now we figure out the positive 3. So in order for us to figure out the positive 3 side, we will use the 3 minus. So we will use a number that is very close to the 3 on the left side. So since the number that is close to 3 in this case will be 2.9999, so we will use the 2.999 to plug in back to the equation. We know 2.99 is a positive number, but 2.99 squared will give us 8.9998, and then when you subtract 9, you will get negative. So that's why when you divide this, you get a negative infinity. So this telling us that on the 3 minus sign on the left side here, this sign will go to negative infinity. So we know this graph is go downwards. So now we know that this is one goes upward, this one goes downward, and when we have a 0, 0 on the x and y intercept, so we know this graph looks like a cubic function, looks like a negative of a cubic function here. So this is how we figure out the middle part of this. And finally, on the last piece is we will use the 3 plus. The 3 plus means we're going to figure out what is the end behavior for the 3 on the right side. And in this case, we use 3.0001. The more 0 you put in, definitely this number will go towards infinity. If you just put 3.1, you won't get into infinity, but we want to get very close to 3 on the right side, so we put quite a few zeros behind. This is positive, and when you square this, you get 9.0000 something. But when you subtract 9, you still end up with 0.0 something. So this one is positive, and when you divide this, this will go to infinity. So what we're gonna tell here is for the function of 3 plus, this function will go to infinity, means it goes up. So this will go like a curvy like this, and it will never cross your x and y axis. You don't cross your vertical and your horizontal asymptotes, because we already proved it that the only point that you cross over on the horizontal asymptote is at 0. And do not forget, your rational functions will never cross on your vertical asymptote. So this is the graph, step 9. This is how we graph this rational function for question 7, h of x, x over x squared minus 9.